Yeah, people use it most
There's
these days.
nothing wrong with that. Hello, guys and girls and people. Welcome to another one-on-one science lesson. So now, me and Mr. An, my students, we are working on modeling the solar system. So yesterday we were at the stars, black holes, nebulae, and understanding the different models of solar system, whether it's like geocentric or whether it's heliocentric model. So now we continue with the origin of the solar system. All right, can you read that, man? All solar
Yeah,
system.
sure.
It's good to just read it
Origin.
because when you read it, you actually do two function. So basically, you read it, it get into your brain, you remember it better, and also it prevents distraction from the outside. Okay, just read it then. Can you?
Yeah. All solar systems start with the
Formation of a
formation
central
of
star.
the sun. The central star is the sun in our solar system. You have learned how a star forms from a swirling cloud of dust and gas called nebula. Matter collects as a central mass with gravity drawing in more and more of it. The force of gravity is sometimes not strong enough to pull all the matter in a nebula into a star. The leftover matter forms an orbiting ring around the star in a flat plane, like a spinning disk. This matter may eventually get compressed into smaller body, such as planet. Leftover matter and the matter start condense into planets. Planets orbit in the same plane. Evidence to this theory. Two main lines of evidence support this model of how the solar system formed. The
Mhm.
sun and the planet all about 4.6 billion years old,
Really
which
old.
means
Really
yeah,
old. They form out about the
which
same
means
time. Mhm.
all the planets orbit the sun in the same direction, counterclockwise, and their orbit are in the same plane of a flat disk-like region of space. Both of these observation would be expected if the sun and planet form from the same nebula at the same time. Types of planet in the solar system. Astronomers think that when the sun formed, the leftover material, which was a mix of gas and dust, formed three types of planet in the solar system. Rocky planets. The four planets closest to the
Rocky planets.
sun.
So basically, some planets are rocky. There's nothing you can
Yeah,
do about it. They're just rocky. I mean, they're made
Mercury.
of rocks.
Yeah, basically.
They're not gas planets. For example, Jupiter, Uranus, Saturn, they're all gas planets. But, um, wait, Uranus and Neptune, basically, they're ice planet, not rocks, and not gas either. So the four inner, like Mercury, Venus, Earth, and Mars, they are rocky planets because a lot of rocks, ground rocks. Yeah. Primary
Mercury,
iron with
Venus,
silicate
Earth,
metal.
and Mars all have similar composition. Their core are made primarily of iron and silicate mantle. They form from dense dust clouds that were closest to the sun. Gas giant. Farther away from the sun, the leftover material was made mostly of hydrogen gas. Temperature were much lower and the gas clouds were not large enough to form their own star. Instead, they form huge gas planet or giant gas giant called Jupiter and Saturn. These planets have no solid surface. Ice giant. At the outmost part of the ring of gas surrounding the Sun, temperatures are very cold. The material here condensed into a huge ball of ice and hydrogen gas. The planet formed were Uranus and Neptune. Like a gas giant, they do not have a solid surface.
Basically, Uranus and Neptune, we found out that they have icy surface, but we don't know exactly if they have solid surface or not because we have not been able to just penetrate deep into their layers yet. You know, it's too far. That's the first thing. The second thing is that our space equipment, it's just not good enough to figure out like what's the inside of that planet. Like how many layers, you have to get in there, and then you have to land on the planet and then study it. But the problem is we have not been able to do that because either it's too dangerous, because sometimes the atmosphere is just really dangerous to enter. Like for example, Jupiter and Saturn, their atmosphere, there's like a lot of storms like that travels at about 1,600 kilometers per hour. It's just like really, really, really strong. They are as strong and as fierce as like bullets flying around.
Yeah.
It's that strong, especially like for Uranus. Oh my god, their wind is really strong. So like bullets flying around, there's no way your space probe or whatever equipment we send there could survive. That's the thing. That's why it's tough to study what's there.
Planets. Put the planets in order. The planet closest to the Sun would be number 1. Venus. No way. Mercury. Mars. Jupiter. Saturn. And Neptune. The distance of a planet from the Sun greatly affects its property, including whether it is a rocky planet, gas giant, or ice giant. Let's find out more about the planet in our solar system. Jupiter and its 4 largest moons, Europa, Ganymede, and Callisto. Orbit or revolution period, year length. The revolution period is the time it takes a planet to complete one revolution or orbit the
Revolution,
sun.
revolve, like swing around, you know.
Yeah, the Earth's revolution began period is just over 365 days, what we consider to be 1 year. Planets closer to the Sun have a shorter distance to orbit, so their revolution period are shorter. For example, Mercury, the planet closest to the Sun, has a year that is only about 88 days long. Planet farther away takes longer to orbit the Sun. Neptune, the planet farthest from the Sun, takes about 165 Earth years to make one orbit of the Sun.
It's really long because Neptune just so far away. It takes 165 Earth year to make one orbit of the sun. It's really long. So it's like every 13 to 14 years. It's like if you divide the sky, I mean the orbit, into 12 periods, which is exactly 12 zodiac signs on the sky. It takes about 14 years for Neptune to finish one sign. So we call it generational planet because basically 14 years enough for like one generation. Like, for example, 9x, Generation Z, Generation something, Alpha, whatever, right?
Yeah,
So basically, each generation will have a different like position of these planets. Like for example, Uranus, different Neptune, different Pluto, for example. So that's why we separate generation according to these planets as well. When were you born then?
uh,
2000 something?
2007, yeah.
Ah, so your Uranus is in Pisces. But someone born before you, like for example 2003 all the way to 1998, they have Uranus in Aquarius. They're a different generation compared to you. And of course, it means that you guys follow different, like, you have a different thinking. Sometimes that could be a problem to make friends, but sometimes doesn't. But a lot of the time it does. Anyway, so I'm talking too much about astrology now. Let's just go back to what we're doing. Okay, 165 light Earth year to make one orbit of the Sun. It's really far, really long. And we cannot even see Neptune.
Ooh.
We cannot even see Uranus and Neptune with our eyes. We have to use telescope.
Yeah. Surface temperature. The sun is the source of heat in the solar system. Planets close to the sun, such as Mercury, have
Blisteringly
blistering
hot surface temperature.
up,
Literally
up to
blister. Literally blisteringly hot. It's just that hot.
yeah. Surface temperature up to 400 degrees Celsius. Those far away, such as Uranus, are as cold as minus 220 degrees Celsius. Earth is just far enough away from the sun to avoid being too hot or too cold.
Mhm.
The surface temperature of Venus is unusually hot, based on its location. It should be cooler than Mercury, but it has,
Hottest of all
but
planets.
oh, this is because Venus has an atmosphere with a high concentration of carbon dioxide and other greenhouse gases. These gases trap the heat from the sun in
In
the
the
atmosphere,
atmosphere,
heating up the surface of the planet.
you
The
know,
surface temperature,
basically the atmosphere of Uranus, I mean of Venus, is just thick CO2 and H2SO4, like sulfuric acid. So basically, it destroy a lot of things that enter that planet because basically it's acid, acidic. And
yeah,
so let's imagine if someone falls into the cloud of Venus, they would first get, eaten up by acid, and then they burn. Their corpses will burn when they reach the planet's surface. That's not the right way to die. Now, the surface temperature of a planet is important.
surface temperature of a planet is important because this determines the possibility of life. Life need liquid water, which can exist only if the surface temperature is within the narrow temperature range between freezing and boiling. Number of moons. Number
Number
of
of
moons.
moons.
Many planets have moons. Moons are large rocks that become trapped by the gravity
Let's
of
just
a
say that
planet.
moons they have to travel around a planet, right?
Yeah,
Remember, planet travel around a star, burning star, but moon they travel around a planet. That's all. Simple as that.
many planets. Moons are large rocks that become trapped by the gravity of a planet and end up orbiting around it. The number of moons around a planet increases the farther the planet is from the sun. Planets closest to the sun have no moons. This is because the sun's gravity is so strong it pulls the moon into itself, where they burn up. Earth is the closest planet to the sun that has a moon. The next one out, Mars, has two moons. The gas and ice giant have many moons. The size of a planet also influences
Influence how many moons it has.
influence how many moons it has. Larger planet have greater gravities and so can attract and more moons orbiting them. For example, the gas giant Jupiter has at least 66
66
moons.
moons. It's just
It's a lot.
really a lot of moons, like a lot of children. Do you know Jupiter? According to astrology, Jupiter means like joy. What is big in your life, like your job. What is big in your life? What is important to you? Because the planet is really huge. It's the biggest planet in the entire solar system. That's why. And Jupiter also means joy, fun, things that is fun, luck. You know. So according to the
Mm.
number of moons, it has 66 moon. It has a lot of children as well. Okay, that's just a way to look at it. Just a different perspective to look at it. Like it has 66 moon, lot of children, a lot of things. Okay. And we are still finding more moons around it. Really, I mean, day by day, I
Yeah.
mean, year by year, we're still finding new things.
Distance in the solar system. Distance in the universe are also larger that they have to be measured in light years. The distance within the solar system are much smaller and are often measured in astronomical units
Astronomical
or
units.
AU. 1 AU is the average distance between the Earth and the Sun, approximately 150 million kilometers. Man, that's a lot. This table shows the distance from each of the planets to the Sun in AU. The distance in the table are average distance. Average are used since the orbit of the planet are elliptical, not circular. So the planet is sometimes nearer to the Sun, sometimes farther away. Modeling distance in the solar system.
Alright, time to answer the questions.
Number one.
Unroll blank
Another one.
31 sheets of toilet paper. Ugh. Unroll. Keep the 31 sheets together. Do not separate them to separate individual sheets. A ribbon of toilet paper runs 3 meters long. The edge of the first piece of toilet paper is the location of the sun. Uh-huh. Mark a dot at the junction with the first two sheets. Start represent the earth. Uh-huh. Sticking out with the toilet paper tears too easily. What units are represented by each sheet of toilet paper? So basically it's the distance between the earth and the sun, isn't it?
Yeah.
So it's astronomical units. Because one astronomical unit, IU, is the distance between the sun and the earth. So each sheet of toilet paper now represent 1 AU. Okay, I'll let you think. Okay, I'm not
Yeah.
thinking for you. Okay.
Hmm.
Hmm? Yes.
Use ribbon of toilet paper. Unit is represented by each sheet of toilet.
Yes, so what's your answer then?
So my answer is
Yes, I'm listening.
based on where you place the dot for what unit is. Sheets of toilet. I think the unit is represented by what unit is represented.
You just unshare your screen again. Okay, share again, please. The right one, please.
Okay. Oh wait, hold on.
Hold on. Okay,
Okay. I
perfect.
think it's
Mm-hmm.
this is astron. Oh, astronomical unit. Units. So it's like so Earth is one astronomical unit from the sun. Yeah. Okay. Four. Use the AU measurement from the table to locate and label the remaining 7 planets on the toilet paper ribbon. When you have marked the location of all planet, lay your ribbon of toilet paper on a flat surface and observe the distance between the planet before answering the question below.
Mm-hmm.
Provide your response to the following question. Where are the dots for Mercury and Venus? Use the AU mission. Where are the dots for Mercury and Venus? Or V and Venus is near to the sun, so
To be somewhere in the first piece of toilet
first
paper, right?
sheet.
Of
Yeah.
course, of course, that's where it should be.
Yeah. Where are the dots for the other 5 planets? Other 5 planets. Five. Where are the dots for it is near it's in between two like in third sheet. Jupyter is
5 times the distance from the sun and the Earth, right? About that.
yeah. So it's about 6 or 7 is
No, it's between. It's around the 6 piece of toilet paper, right?
Yeah.
Because 1, 2, 3, 5.2 is like around a 6 piece of paper. The sixth, the sixth, the number 6. It's basically the it's ordinal number, the sixth piece of toilet paper. Wow, this kind of comparison, this kind of thing that use toilet paper is actually quite useful. I couldn't think of something else more practical way to compare.
So Saturn is Saturn. Saturn is Saturn is about maybe around like
Saturn is like 10, the 10th piece of toilet paper.
yeah 10. Saturn is
And
here
the 10th piece of toilet paper.
down piece of paper. Uranus is so it's like around it's 20.
It's really far away.
Yeah. How is near the
Mm-hmm. It's just near the 20 or something. Wait, how many pieces of toilet paper
It's
I
31.
use?
31.
31, right? So it should not exceed that. Otherwise, you can stick extra, like, stuff in there. Like sticky paper or something like that.
Yeah. 20 piece of toilet paper and Neptune is like Neptune is the closest. It's the nearest to the 31, 31 piece of toilet paper.
Mm-hmm.
Yeah. Dot for Mars is in the middle of the second sheet, and the dot for Jupiter just into the fifth sheet. The dot for Saturn is in the middle in the ninth sheet, and the one for Uranus is into the 19th sheet. The dot Neptune is just into the 31st sheet.
The 31st sheet.
31st, yeah, sorry.
Mm-hmm. Just really, really far away.
Yeah, very far.
Mm-hmm.
Comparing planet. Important information about each of the planet can be summarized on a planet card. Here's an
Actually,
example.
light, light from the sun, it takes about 7.5 seconds for light from the sun to reach the Earth. So
It's
basically,
fast.
what if we look at the sky now, we see the light. That is actually the light from its past 7.5 seconds. It's
Yeah.
not the light it is shining right now. It's just the light that it's about 7.5 seconds ago. And you know, light travel very fast. So that's just how far away we are from the sun. We are yet to find something traveling faster than light.
Okay. Earth. Name Earth positions from the Sun, third planet. Revolution period. Orbit. 365.25 days, 1 year. Diameter. 12. 12,756 kilometer. Average distance from the Sun, AU or kilometer. 150 million kilometer. 1 AU. Average surface temperature or rain, degrees or Kelvin. Average is 15 Celsius. Description of planet. Solid, thin crust made of rocks. Molten, liquid rocks below. Core of iron and nickel, which are magnetic. 70% of the surface is covered in water.
Mhm. Which is,
Description.
a blessing, because without water, nothing. I mean, without water, no life would exist. And Earth is just very blessed with a lot of water and a very habitable environment. That's why life could appear. No rings around Earth. We have only one big, massive moon.
Yeah.
Interesting feature, only planet in the solar system able to support all forms of life. I mean, it's the only planet in our solar system who that can have life because it's just in a very perfect zone. It's called habitable zone. Habitable zone. Habitable means like you can live in there. Because if it's too extreme, nobody would live, will be able to survive there. But we are
Yeah.
inside that habitable zone, so that's why all life form can exist.
To be equal. The moon. The moon has a rocky structure like the Earth, but doesn't mean they are identical. One big difference is that the Earth core is made of iron,
When the moon is
while
not.
the moon is not.
Mhm.
Where did the moon come from? The best theory said there was a
Collision.
collision between the newly formed Earth and another planet-sized object about 4.5 billion years ago. This massive collision caused a chunk of the Earth's surface to break off and eventually become the moon.
Which is very weird.
Yeah,
How could
this
they break
explains.
up? How could they break up and then be in the same place to congeal or to stick together to become a moon? I mean, it's just a theory. That's why.
Yeah, just a theory. Well, I think the moon's like came from somewhere like rock, smashed into rock and just like erupted.
It could be a massive it could be a massive object on space that just traveled freely, and then eventually it got attracted by the Earth's gravity, you know,
Atmosphere.
and then it started to rotate around the Earth because of our gravity.
Yeah.
Or that's the theory I have. Maybe it's alien in origin, like it just traveled from other systems, and then it enters our system somehow, and then it got attracted by the Earth's gravity. Maybe, who knows? But the whole theory about collision with something else just seemed absurd to me. Another
Mm.
planet-sized object. Yeah. So if it's made of the
Maybe.
same material surface of the Earth, it means that they have the same. Probably they have the same origin, but it
Yeah.
doesn't absolutely mean that they have to be from the same origin. You know, like for example, two people they share the same character, like same personality. It doesn't mean that they are from the same family, right?
Yeah.
So the same thing happens here. If it's made of the same material as the surface of the Earth, it doesn't mean 100% that the moon has to be from Earth in origin, right? It is about the same age. Well, but still, it's not 100% sure that it has to be from the Earth. Earth's surface material only, not its iron core. Could be. I mean, if you combine these three together, it's quite solid evidence to support this theory.
Yeah.
But each of them, not really. But if you combine these three together, it's quite solid evidence.
Moon's moving. Moon's revolution and rotation period.
Uh huh. Yes.
Composite image of an astronaut in front of the far side of the moon. The same side of the moon always faced the Earth. No matter when you view the moon, it wasn't until the American Apollo space program sent spacecraft to orbit the moon in 1960 that human
That human
first
first saw the
saw.
far side of the moon. It's called the
You,
dark side of the moon, you know, or the
yeah,
far side of the moon. Basically, the side this is the side that we don't see because only one side of the moon is always facing the Earth, but the other side is not, which is weird.
the
Dark
moon's.
side of the moon. Basically,
So
there's a lot of music and novels that talk about the dark side of the moon, you know, because
it's
people
like there's
always try
alien.
to hypothesize and then they romanticize it. They make it romantic, romanticize it. They use the imagination, talk about it all the time, you know.
Yeah.
There's even a music album named Dark Side of the Moon, you know. And it's one of the most famous music album in music history. Dark Side of the Moon by Pink Floyd.
Moon is rotating on its axis. Why does the same size always face the Earth? The reason is that the moon's revolution and rotation are the same. 28 for each. 28 days for each. That means it takes the moon exactly the same time to make one rotation on its axis it takes to make one rotation of the Earth. This rarely happens with objects in space, even though the moon is always show the same face to the Earth. The moon appearance does change over its 28 days journeys around Earth. Sometimes the whole moon is visible, full moon. Sometimes only some of it is visible, and sometimes the whole moon is in
The
the
shadow.
shadow, new moon. These different views are called phases of the
Phases of the
moon.
moon.
The moon does not give off its own light, but it's lit by the sun. The difference between
Phases,
phase
the changing angles.
of the sun shining on the moon as it orbits the Earth. It it takes 28 for the moon to cycle through its phases. That's why many ancient calendars set their
Ancient,
months to
many
be.
ancient, not Asian.
Oh, sorry, I said Asian.
Ancient, not Asian. Many ancient calendar.
Ancient,
Ancient calendar. Set their
ancient.
months to be 28 days long.
You will explore for yourself how the phases are created in the following activity. If you the following image, full waxing gives first quarter, waxing crescent,
Mm-hmm.
new
One in crescent, third quarter, I think one in EBS. Oh my god, label the phases.
disable the face. So this is a waxing crescent.
Yeah, what's in crescent?
E is full.
Full moon. C.
C is
Wait. A is waning crescent, not waxing. A
waning.
is waning crescent, and C is waxing crescent.
Right. D is first quarter. E is E
Uh,
is wait what?
waning EBS.
Waning gibbous. Yeah, yeah,
EBS. And F is like a half. Wait,
yeah.
is it
So
third quarter?
it's third quarter. Yeah. F is third quarter.
G is like new moon. We don't see
H.
nothing.
Yeah.
Basically, G is like new moon when we don't see anything.
Just like invisible. And H is
Waxing
waning,
crescent again.
waxing, waxing.
It's just like from different angle you see it there like that waxing crescent.
Other object in the solar system. There are other objects in the solar system beside the planets. Press on each tab to learn about more. Dwarf planet. Dwarf or minor planet are about one-fifth the size of the Moon. The best dwarf planet in the solar system is Pluto. Pluto was considered to be the ninth planet when it was discovered in 1930, but it
But
lost
then
status.
it was stripped off. But it was stripped off of its status as a planet in 2006 because according to new planetary classification system, they say no, you're too small to be a planet. It's not like the other planets. So basically,
Yeah,
all the planets they travel in the same plane, same plane. But Pluto's like like that. It's just weird. It follow a weird planet orbit. compared to all the rest of the planets. So it's just different. So that's why we don't classify it as a planet anymore. In 2006.
Pluto appeared to be large enough to be a planet, but recent observation show that Pluto is not like the other planet. First, its orbit is not the same plane as those of the other planets. Second, it appears that Pluto shares its orbit with lots of other rock and ice, and the strong gravity of real planet cause cause um,
Wait a moment.
cause them to gather up this material as they orbit the sun. For these two reasons, astronomers decide to reclassify Pluto as a dwarf planet. This image shows that Pluto orbits on an angle compared to the other planets in the solar system, such as Neptune. Comets. Comets are small balls of ice and dust. They are sometimes called dirty snowball. They
Because
are
they're actually
probably
dirty because there's a lot of dust in there.
yeah. They are probably sometimes called dirty snowball. They are probably a piece of this original material left over when the sun was born nearly 5 billion years ago. Comets have very large elliptical orbit that are not on the same plane as the orbit of the planets. Comets have an orbital period of between 20 and 200 years. As a comet approaches the sun, it becomes heated. The surface of the ice melted and give off steam of water vapor and small particles that become visible as the comet tail. When the sun reflects off this material, one of the most famous comets, Halley Comet, makes an appearance approximately every 76 years. It was last visible from Earth in 1986 and will not be seen again until
2061.
2061.
So basically, just go far away from us now, and we'll come back. So in one lifetime, you may see it once, or maybe you're lucky if you can see it twice.
Yeah.
I mean, living in the city, it's hard to see anything. Even though you might see, like, for example, blood moon or other kind of astronomical events, but living in a city, there's so much light pollution, it's tough to see anything. So I'm like, meh, nah.
Hmm.
Okay, let's just take a little short break, shall
Yeah.
we? Okay, let's continue now. Comets. There is snowballs. So basically, comets are extremely old. They're just what the leftover from when the sun was born nearly 5 billion years ago. They're just wandering around space, just traveling like that. And they burn, you know. They burn.
Ooh,
They do burn.
man, that's hot.
And in the old time, they say that when you see planets, when they see comets, it's a sign of some things going to happen. but I don't believe so.
It's a theory.
Hmm.
Comet approach the sun, become heated. Surface of the ice melt and gives off a stream of water vapor and small particle. There's a small particle that become visible as comet tails. When the sun reflects this material, one of the most famous comet, Halley Comet makes an appearance approximately every 76 years. It was last visible from Earth in 1986 and will
1986,
not
and
be
it's not been
seen.
until 2061. It's a long way to go. I probably, if I still survive by then, if I'm still alive by then, I would probably see it. But no, I
Yeah,
won't. The cloud asteroids. It's just an artist's impression because basically we don't have many pictures.
yeah.
So asteroids just like space rocks made of carbon and metals orbit the sun. Asteroids range in size from some grams, roughly 100 kilometers across. They're just like a lot of different space rocks.
Different space rock.
There's a huge asteroids belt surrounding Jupiter and Mars. Between Jupiter and Mars, there's a huge like asteroid belt. Lots of space rock around that region. So it's like separating the inner planets and the outer planets because of those space rocks or asteroids. There you go. That's what I say. Most asteroids are found in orbit between Mars and Jupiter. Yeah.
Yep. Most asteroids are found in an orbit between Mars and Jupiter. The toilet paper simulator of the solar system you did earlier show a large gap between Mars and Jupiter. This gap is where most of the asteroids are found. Some asteroids have orbits that take them closer to Earth. Occasionally, they have been on a collision course with Earth. The largest such collision in recent history was an asteroid, or probably a comet, that flattened 2,000 square kilometer of forest near the Solid Tunguska, a river in Russia, in 1988. There were no human casualties.
No human
Meteor.
casualties.
Meteor are asteroids that get drawn into Earth's atmosphere by gravity. Most eventually
Gravity.
crash into ground. Their incredible speed causes friction with the atmosphere, making them burn up and producing a brilliant blazing trail through the skies. As a result, they are commonly called shooting stars.
Shooting star. just like from the sky, it just fall down like
Yeah,
that, shooting
see,
star. Like the star has been shot down, or something like that. No, it's not shot
yeah.
down. It's just shooting itself.
Weird. Meteor shower occur when the large number of meteors enter the Earth's atmosphere all at once. For example, the Perseid meteor shower happens mid-August every year over several days. These events are spectacular to watch if the night sky is clear and cloud, cloudless. Sorry, with at least one meteor visible every minute, though their appearance can be very dramatic. Most meteors are smaller than golf ball. A meteor usually completely burns up before it reaches the ground. If the original meteor is large enough, however, some of it will reach the Earth's surface. The object that strikes the ground is called meteorite. Meteorites strike with an incredible force, but because they are usually so small, they cause little damage. Every few million years, through a really large meteorite collide with the Earth, this can result in major destruction. The impact can cause huge fire across the globe and change the climate for centuries. May wish to visit your mother, son, solar system.
Revisit the model. Just revisit it and you will see. Sorry.
Solar,
Wow, this sounds like a good model now.
yeah,
Really close. And Saturn is really far away.
that's a lot. Sun,
There you go, the thing surrounding it. Just flying around. What?
oh, it's the,
Oh, it's the asteroids. Oh no, it's the comet, right?
yeah, comet.
Interesting. So look at the planet scale. Actually, the planets are not that big. In reality, they're just so small compared to the sun. So that's why they
Yeah,
say 20 times larger relative to the sun.
Earth, it's moving so fast.
Our Earth, our home.
So that's the, it's like this. The moon's like traveling very fast
Mhm. The moon
because the
moves
day
quite
of,
quickly, 28 days surrounding the Earth.
yeah. Mars, Jupiter, Saturn,
It's just far away.
yeah, very far. Uranus,
Uranus, yes. That blue. It's not exactly blue. It's like pale green blue. because of the methane gas on it, and then a lot of other kind of gas that produce that kind of typical what's it called, icy green
Oh,
color, and Uranus is like bluish.
yeah.
Let's study a bit more until like 12:15 or something.
Neptune, planet Pluto.
Pluto is just really cold.
Yeah, it's
It's
so
so far
far away
away.
from the
So
sun.
-225 degrees Celsius average. And the gravity is just so small too. And hardly comets. So the closer it is on the sun, of course, the more it will heat up.
Yeah,
Gravity extremely low because it's such a small object. So the bigger the object is, of course, the more gravity it has. So when you're near to Jupiter, the gravity is really high, like 11 times more than the Earth. Like for example, if you weight 60 kilos now on Earth, you should weigh about 666 kilograms on Jupiter, something like that. Really
yeah,
heavy, because the gravity of Jupiter is like 11 times more than the Earth.
it's true.
Well, how about
Equator.
from Earth equator? Okay, equator is exactly
Um,
where Singapore is. Equator is about where Singapore, Saigon, Singapore. Maybe Singapore is a better place. Like it's near to the equator.
yeah,
Real from Earth. Okay, let's do real scale, planet scale. You can switch it back to like real scale, and you can see planet
okay,
distance.
planetary. Where?
If you switch that scale back to all the way to the left, and you can see that planet scale is just like the moon's around this the Earth's like. It looks funny in this simulation.
Yeah, like it's going so fast. Like,
Hmm. It's fun to have this kind of simulation.
yeah,
How about like you change the planet distance back to like to the left, all the way to the left? You will see they're not that close
yeah,
because now we're looking at it like 100 million times closer, but in reality, no, it's really far.
uh-huh. What errors in the app? And that's it too. Just moving on to 3.4, exploring space.
Exploring space. Oh, luckily, finally we come to a new chapter. A new chapter. Exploring space. Sputnik 1, the Russian, first artificial satellite launched by USSR. You know, the USSR, like the United States of Soviet Republic.
You,
Basically, USSR is the former Soviet Union. Now there's no more. It
ah,
dissolved. It dissolved around 1989, exactly the same year I was born.
oh,
You should read about the story of the Soviet Union to understand more about it. It's a very important part of history.
in October 1957, Sputnik 1, the first artificial satellite launched by the USSR, the former Soviet
Basically,
Union.
the USSR is comprised of like 18 different nations, but mainly, of course, the Russians are the biggest country in that USSR. They joined together to produce these space programs, and the launch of Sputnik 1 in 1957 took the whole world by surprise, especially the American, because the American also has a space program as well. They were trying to compete with the Soviet.
Oh,
So the two sides is like competing. Who will be the first one? Like,
who is better? Okay,
mhm.
something like that.
And that was during the Cold War. They were sending spies. They were spying on each other. There wasn't any kind of real war happening at that time, but they were sending special forces and spies against each other. It wasn't a real war. It's just a Cold
Oh,
War when everyone tried to build up their weapon sources, weapon cage, weapon what's it called, arsenals. So everyone would try to get better guns, better airplane, better ships, better everything. But then, luckily, World War III did not happen. hmm
that's lucky.
hmm You should read about the Cold War as well. Right after World War II, that's where Cold War is,
I
and
heard the
it's
Cold War before.
sorry.
I heard about the Cold War before.
hmm It stopped when the Soviet Union dissolved in 1989.
Yeah,
Luckily, well,
lucky. Anyway, was the first project object positioned in space that began our modern day understanding of the universe.
Mhm.
The age of space exploration had begun. The launch of Sputnik 1 took the world by surprise, especially the Americans. This was the height of the Cold War, and Americans suspect that Sputnik was either a method of spying on them or a means of attacking. This event triggered an interest in space exploration in the United States and its allies, including Canada. US direct enormous technological and financial resources towards space exploration, include an emphasis on teaching mathematics and the physical and science in school. This learning activity gives a brief history of space exploration, focus on its benefits and risks. You will also learn about the current future space mission, including the possibility of sending people to Mars. The race to the moon. After World War II, relation between the US and the Union Socialist Republic, USSR, or Soviet Union became strained. Each nation accused the other of developing nuclear weapons designed to destroy the other. Both countries feared that a war could break out between them at any time,
Hmm.
so they rapidly expanded their
Yeah, military and missile
military.
program. So basically, each side rapidly expanded their nuclear weapons arsenal. So each side has about like 2,000, I think, or maybe 4,000, I'm not so sure. Nuclear missiles always ready to launch at their enemy. So at that time, 1967, 1968, every year people are afraid of a nuclear weapon strike.
Yeah.
So everyone in America, basically, they have to have like some kind of like underground vault, underground tunnels to hide away in case they got attacked by nuclear weapons. So
Yeah.
um, whenever the radar alarms people about the nuclear weapon, imminent nuclear weapon strike, people have about 5 to 10 minutes to get to the nuclear vault, to the shelter.
Mm.
Otherwise, they will get vaporized within seconds. So it was not a very safe era to live in, but a very exciting
But
era.
but
Very
I heard
exciting.
that in like they were like Americas and the Soviet Union were like threatening each other, but they didn't actually do anything. So they
No,
just
did not. Luckily, because they both know that if they provoke one another, then the other will retaliate with like nuclear weapons, and the amount of nuclear weapons that each side possesses is enough to destroy Earth 10 times. So it's like everyone's gonna die. No one is gonna profit from that war. They both knows it. So that's why they just amassing nuclear weapons without doing anything. One thing we could do, you know what we would do? Use that weapons, shoot at like incoming space rocks, and then it could not hit the Earth. Like for example, if there's a huge meteor that will hit the Earth, I mean we can aim our nuclear weapon at them and then explode it, blast it, or just shift it into a different direction. Could be a way.
yeah.
I mean, otherwise, it's still better than shooting nuclear weapon at each other.
After World War II, relation between the U. During the Cold War, each country tried to develop more powerful nuclear weapon than the other. The competition became known as the arms race.
Arms race.
In October 1957, the arms race became a space race where the USSR successfully launched the world's first orbiting satellite, Sputnik 1. This basketball-sized satellite was launched into orbit using a powerful new type of rocket that could potentially be used to propel a nuclear weapon. The American people were shocked to see how far the Soviet Union space program had advanced during the Cold War. They were worried that if the Soviet Union controlled space, then they could defeat the American if a war broke out. This fear spurred the US into rapidly developing its own space program to compete against the Soviet. In 1958, the nation Aeronautic and Space Administration (NASA) was created to oversee all space missions by the United States. The space race was motivated as much by politics and pride as it was the desire for scientific discovery. In 1961,
Hmm.
U.S. President John Kennedy pledged that the
US
U.S.
will put a
would,
person on the moon before the end of the decade. Uh-huh.
at the time, this seemed like an impossible dream,
But
but
human
it
can
led
dream,
to
and because we dream that we achieve something better, it led to an incredible period of technological innovation in space travel. If we don't dream, then we won't try. But if we don't try, we want to achieve better.
yeah. In 1960, the race to put a person on the moon ended 8 years later on July 21, 1969, when the American astronaut Neil Armstrong and Buzz Aldrin became the first people to walk on the moon. Space exploration timeline. Now you look at the timeline of space exploration from 1957 to 2012. Pay attention to the various countries' space program and achievement. Timeline space exploration.
Satellite launch.
Launch and successfully orbit the Earth for 3 months. As you can see from the timeline, the US was the first to land a person on the moon, but the USSR was the first to achieve many
Many other
other
significant
significant ones.
milestones. Mercury, Gemini, and Apollo, huh? Three space programs. Apollo 11. It's been half a century already since the last time human ever visited the moon. Now we came back. We are deciding to come back now. Half a century, like 50 years already. Yeah, I just don't understand why we human doesn't build a base on the moon or something like that. It's been 50 years. maybe after the Cold War ended, there's no reason, there's no competition anymore, you know, because your opponents are literally, how can I say, defeated. You no longer have an opponent to fight.
Yeah.
So maybe that's, you know, the lack of motivation to continue, and also science. American science, they receive less funding than before. So that's why just like, you know, just continuing on, but very barely, you know, it's like that. But during the Cold War, of course, the American side, they received a lot more money.
What? During the later moon landing, astronauts made use of the lunar rover to explore and collect samples from the moon's surface. These samples were studied to determine the composition of the moon. Canadian contribute to the space race.
Race.
Canadian play a big role.
Oh, because you're learning the Canadian program, that's why they have to include this part.
Yeah.
Like part of the, you know, way to make the country looks great is, of course, what did we contribute to the space rate? If you learn the French program, for example, the French will be like, what did we contribute to the space race? Nothing. I'm just joking. Of course, they did something. Did you know that Vietnam actually, there's one person, the first Asian person to enter the outer space? Do you know there's one Vietnamese person? That's, I think he is a general now. His name is Nguyễn Tuân, you know?
Oh, cool.
I'm not so sure exactly his name, Tuân something. But he's prestigious, of course. He's old now, but of course he should be old by now. And so he was the first Vietnamese and the first Asian to be on the outer space. That is like an honor. A huge one. Alright, I think we should stop now and then we can continue this one like maybe next week, Tuesday, something.
Sure.
Alright. Okay, that's the end of my videos. Please like, share this video with your friends, subscribe to my YouTube channel, and press on the bell button next to the subscribe button so you can get notified about my new uploads, okay? You can also press follow my Facebook, but please don't add me on Facebook as friends, okay? Cảm ơn các bạn đã theo dõi nha. Các bạn hãy nhấn vào like, chia sẻ video này bạn bè các bạn. Nhấn vào nút đăng ký kênh YouTube mình và nút cái chuông kế bên cạnh để đăng ký kênh á, để mà các bạn sẽ được thông báo về những video mới nha. Các bạn cũng có thể nhấn vào nút theo dõi Facebook mình nhưng nhớ đừng kết bạn Facebook mình nha. Thank you and see you. Bye.